Now, the Pfizer vaccine, when it comes, will need to be stored at ultra-cold temperatures, and experts have warned that its introduction could be slowed by the need for specialist equipment. Well, let's bring in Dr. Anna Blakeney, Research Fellow and Bioengineer at Imperial College London. Good to talk to you. So just talk us through the logistics of this. This vaccine apparently needs to be stored at -80. How can you do that?
Yeah, so the RNA is actually encapsulated within a lipid nanoparticle, and that helps it get taken up by your cells once it's injected. And the problem is because RNA is a relatively new technology, it doesn't have great stability that's been developed yet. So those particles need to be stored for now in most formulations at -80 degrees. We have these commonly in the lab. So in our lab, we have a -80-degree freezer, but obviously they're not common in most clinics that you may get vaccines in. So obviously many people are now starting to focus on this and rapidly trying to figure out what's a better way to store this, and are there other formulations that have different storage conditions.
And what about transportation? Can you get lorries, for example, that have this -80 freezer capacity?
I highly doubt it. I think the strategy is really to package it in kind of however much you would be sending to a certain clinic, and have it kind of in a more of an enclosed container. So we regularly do this actually to ship vaccines to collaborators and stuff like that. And so it is possible. It's just a lot more logistically challenging than if you were able to send it at -20 or 4 degrees C, for example.
And it only lasts for 24 hours when it's not at this temperature, I understand. So again, logistically, this is going to mean daily deliveries, isn't it?
Yes, potentially. So obviously, if you are able to pack it in a storage container that holds it at -80, this theoretically would actually be able to last for up to a week, depending on how much dry ice or whatever you were able to pack into it. But the problem is that when the particles are stored at a higher temperature, like -20 or 4 degrees Celsius, they start to aggregate together and form larger and larger particles. And because of that, they just don't work in the same way. So the vaccine effectively loses its efficacy.
And in terms of the actual freezers that you do use in the laboratory, these ones that do go down to -80, you say they're not very common, but there must be a few of them in academic institutions, for example, around the UK?
Yeah, absolutely. And that's actually kind of an interesting point. Obviously, they're really common in labs and universities because we use this for a number of different samples. But even if you were thinking about trying to kind of utilize that already existing infrastructure, basically all of the -80s that I know are generally completely full because everybody is so keen to use that storage space. So it's possible, and obviously this is a really pressing matter, but there's not very many that are just not used and open to the general public at this time.
There has been some talk about it being turned into a powder, which would not need to be stored quite so coldly. How quickly could that happen?
Yeah, exactly. So there's actually been a lot more progress on that type of formulation in the field. So essentially what they do is they make the same particles, put in a different what are called cryoprotectants, where you put it in and you're able to then freeze dry it. So you take out all of the liquid from it, and this stops the particles from aggregating. And this typically just increases the storage temperature and time for essentially any formulation. And so if they're able to do that and get that working, then all you would have to do is store it in the fridge or a -20 potentially, and then reconstitute it, which means to add water right before you are going to inject a patient.
Wow. And I mean, we're talking about the issues here in this country, but if we're looking at the whole world, very hot countries, obviously, this creates even further issues. I mean, is the fact that it has to be stored so coldly going to affect the ability to get it to some parts of the world?
I think this definitely does present challenges, but obviously, if you're able to, in rural places in the UK or the US, obviously they don't have -80 storage freezers either. And so, if you're able to really get a good technology for these packing containers where they're able to withstand a certain temperature for a certain number of days, I think that technology is also what we would be sending to more hot climates.
It's fascinating stuff, Dr. Anna Blakeney. Great to talk to you, Research Fellow at Imperial College London. Thanks so much.